Hey everybody, this is Miss Eisencraft with Unit 3, Lesson 9, Practice Problems. So we assigned page 67, numbers 1 through 3, 6, and 7. All right, let's get going. All right, what is the length of segment DF? So you already color-coded what's corresponding. It looks like this was reflected to trick you a little bit. Okay, so this side 8 corresponds to this side over here, and this 6 corresponds to the 18. If you notice that, you might see easily that if it was scaled up, it was a scale factor of 3, so this needs to be scaled up to make a 24. If you didn't notice that, you could go 6 is to 18, orange is to orange, as 8 is to x, and if you multiply, you're going to, no matter how you do it, you're going to get 24. You could do cross products, okay? But that 24 over 8 equals 18 over 6. Lots of ways to see that that's proportional. You did need to notice that to match up corresponding sides that was flipped, though, reflected. Okay, in triangle ABC, A is 35 and angle B is 20. Select all triangles which are similar. So we need at least two angles to match by angle similarity theorem, triangle similarity theorem. So triangle DEF, where angle D is 35 and E is 20. Yes, two match. We're good. So this is a good one. Okay. 35 and 30. Well, we have one, but we know when we have two known angles of a triangle, the third is locked in, right? By the triangle sum theorem, we need 180. So if you have 35 and 20, right, I don't want to mess up camera. 35 plus 20, is 55, and so that leaves you 125 degrees left over. So the third one, my little thought bubble, my third degree has to be 125 degrees. So I know these two, and by triangle sum theorem, I know the third is 125 degrees. So I don't have any spot for a 30-degree angle. Okay, 35 and 125, yes. So the other one would have to be 20 to complete the 180. So there is that other angle that would work by triangle sum theorem. We have a 20 and a 125. Hey, yo, there's the 20. There's the 125. Yep. It just left off the 35 degrees. And last, how about a 20 and a 30? No, you wouldn't have. That would not be good. So just A, C, and D. Okay. 1, 2, 3. All right. This one's a little bit weird. First glance, you're like, oh, are those vertical angles? No, but they still might be the same. Okay. How can you tell if they're similar? Well, we need two angles that match. Right now, we have one. We have the 36 and the 36. Well, let's complete both of those, this missing angle in both triangles by the triangle sum theorem. The top one, if you have 123 plus 36, you have 159. That leaves you 21 degrees. Hey-o, that's that guy. And so 36 plus 21 must leave 123 degrees for this guy. So by triangle sum theorem, now we have two matching corresponding angles. So yes, triangle sum theorem, helps us see corresponding congruent angles, right? And we have all three. Okay, yay, 4 and 5, skip those. And then we have 6 and 7. Determine if each statement must be true, must, possibly could be true, or definitely no way couldn't be true. All right, an equilateral triangle and a right triangle could be similar. Well, we need two angles to be the same. Well, in order to be called an equilateral, you need all three to be 60. You could never have a 90 in an equilateral, and we need a 90. So then you could think, well, what if I had a 60? A right triangle has to have a 90, right? And could you have a 60, 60, 90? That would be too many degrees. So this is never could be true. Definitely can't be true. Definitely cannot be true. Again, if you tried to draw a 90-degree angle and you're like, okay, I need at least two to match, you would need to do 60, 60 for angle, angle to work, but then that wouldn't, it would break the triangle sum theorem. You couldn't actually make a triangle. Okay. Could you have a right triangle and an isosceles be similar? Okay, remember we need two angles the same. So could I draw a right triangle? Okay. And then I can't have 290 and a third, but could I have these two guys equal each other? These two? Yeah, so if you have 90 degrees here, there'd be 90 left over. You could split that equally and have 45. 45. Yeah, you could have an isosceles that's also a right triangle. So it could be true, but there's lots of isosceles that are not right triangles. So it could be true. You could have an isosceles that is similar to a right triangle. Okay. All right, finally, number 7. Quadrilaterals Q and P are similar. What is the scale factor of the dilation that takes P to Q? So Q, they're telling you, is the image, and this is the original. So you take one pair of corresponding sides. I'll take this and this, right? Image over original, 5/4. Oh, so sorry. 5/4. This one right here. All right. Smell you later.